Okay, so in this video we're going to be solving warm-up problems for day 3. I will include a link to these warm-up questions so you can work through them on your own, and then as you go through you can enter the answers that you got for each question. Okay, so we're going to start with question number 1. And question number 1 says a flying saucer traveling at 200 meters per second accelerates at a rate of 2 meters per second squared until it reaches 210 meters per second. Calculate how far the flying saucer travels as it speeds up. Okay, so I want you to pause it here and see if you can answer this question on your own, and then record your answer before I go over the question. Okay, so let's enter this question. Flying saucer traveling at 200 meters per second. So meters per second, this is a velocity, and this is actually going to be my initial velocity because that's how fast the flying saucer is traveling at the beginning of the problem. Okay, that just comes first in the problem, and plus it tells me it's going to speed up and eventually reach 210 meters per second, so that's going to be the final velocity right there. Now the acceleration is here. Remember, you can always look at units for context clues. Meters per second squared is always the unit for acceleration. Okay, nothing else has that unit. Okay, so that's going to be the acceleration, and then the question, how far is always about displacement. Okay, so some of you have asked me about how do you know which equation to use. Guys, you have to go through this process first, okay? Because when you do a constant acceleration problem like this one, you have to have 3 pieces of information given to you, plus 1 piece of information that you're trying to find, 1 unknown. You have to have those 4 things because those 4 things tell you which equation to use. You have to use the equation that has those exact 4 things. In other words, I want to use the equation that has VI, A, VF, and D. Okay, so I'm going to look at my equations. I'm going to pick the middle equation because that's the only one that has all of the information I have. I'm going to write down my equation and then I'm going to plug in. Okay, so my equation is VF squared equals VI squared plus 2ADX. Okay, remember dx is displacement. The reason that dx is there is because the flying saucer is traveling side to side. Okay, later when we do free fall problems, we'll see we use dy to indicate displacement that's up and down. Okay, so that's why it's dx. So anyway, I'm going to plug in. I have 210 squared for VF equals V initial, which was 200 squared, plus 2. The acceleration is also 2, and then dx is my unknown. Okay, so to get dx by itself, I need to simplify a little bit, and combine like terms and whatnot. Something I want to point out is this 200 squared is not being added to this 2 times 2. Okay, this 2 times 2 is attached to this dx. Okay, so make sure that you're only combining like terms. Just like 2x plus 3 is not equal to 5x because you cannot combine unlike terms. Okay, so just keep that in mind. So the first thing I'm going to do is I'm actually going to type into my calculator 210 squared. I'm going to write this over here so I have space. That's 440,000 or 44,100 equals 200 squared. I type that into my calculator. That's 40,000. 40,000 plus, now I can combine these two because they're both attached to the dx. 2 times 2 is 4, so that's 4 dx. And now it's just a matter of algebra. I say what's being done to dx, it's being multiplied by 4, and it's being added by 40,000. And to undo those two operations, I have to do PEMDAS backwards. So my first step is to subtract 40,000 on both sides. Okay, remember, anything you do to one side, you have to do to the other side. That's like the golden rule of algebra right there. Okay, so if you subtract that on both sides, on the left side, you get 4,100 equals, on the right side you have 4 multiplying dx, and so to undo that multiplication we need to divide. Okay, so I'm going to divide both sides by 4. 4,100 divided by 4 is 1,025, and so dx is equal to 1,025 meters. Okay, so that's how far the flying saucer travels as it's speeding up. And by the way, if you want to know what that is, it's a little over 1 kilometer, which is a little bit less than a mile. So there you go. Okay, that is question number 1 on the warm-up. Now pause it there if you need to look at that. Hopefully that's the answer you got. If that's not the answer you got, hopefully you figured out by now where you went wrong. Okay, so let's move on. Question number 2. It says, use the velocity time graph shown below to answer the questions. I've had some people ask me where to start on these graphing questions. The first place to start is always to figure out what type of graph am I looking at. In this case, we're told right away that this is a velocity time graph. And the type of graph is important because the way you interpret the different graphs depends on what type of graph it is. So for example, if this was a position time graph, if we wanted to find the velocity from a position time graph, we'd be looking for the slope. If we want to find the velocity on a velocity time graph, we're just looking at the actual graph itself. Okay, so for example, right here in this first segment right here, this is a constant velocity of 4 meters per second. Okay, because this is a velocity time graph and you can see the graph is constant at 4. If this was a position time graph, let's say I just changed this v to an x, and I made this a position time graph, then the velocity here would be 0 because the slope of this line would be 0. Okay, and so the way you answer questions and the way you interpret the graph depends on what type of graph you're actually looking at. Okay, so you need to know first of all, what type of graph am I looking at? This is a velocity time graph. Okay, keep that in mind. Now the first question says calculate the acceleration of this object between t equals 0 seconds and t equals 2 seconds. I've also had some people ask me, what does that mean? T equals 0 seconds and t equals 2 seconds. How do you answer a question when it's giving you a range of times? Well, time is down here on the x-axis. So when I say between t equals 0 seconds, when t, which is on the x-axis, is 0, the graph is right here. And when t is 2 seconds, okay, remember time is on the x-axis, the graph is right here. So in other words, the first question, part A, is basically asking me to find the acceleration during this first segment of the graph. Okay, that's what the question is asking me. Now, I can do that because I know on a velocity time graph to find the acceleration, I should be finding the slope. Now, I could use the slope equation, there's nothing wrong with that at all, but in this particular case, I don't actually have to do that. I can say right away that the acceleration is 0 meters per second squared. Now there's two ways to think of this. Either you can look at this part of the graph and realize, hey, that's a horizontal line segment, and if it's a horizontal line, it has no slope, because slope is rise over run, and it has no rise. So the slope here is 0. Or you can realize that, hey, the velocity is not changing. It's staying at 4 meters per second. And if your velocity is not changing, that means you have no acceleration. By definition, if you have constant velocity, which we do in this first segment right here, then you have 0 acceleration. Okay, so however you want to think of that, you don't actually have to do much work to answer that first question. Now, for 2b, calculate the acceleration of the object between t equals 2 seconds and t equals 4 seconds. Again, these are x values. So t equals 4 seconds. T equals 2 seconds. Here's t equals 2 seconds right here. And t equals 4 seconds is right here. And so basically this is asking me about the second segment of the graph. Right? I want to find the acceleration on a velocity time graph that can be found by taking the slope. I pick my 2 points so I can use my slope equation. Remember, the equation for slope is y2 minus y1 divided by x2 minus x1. The point on the left, I always make that point number 1. And remember, when you do an ordered pair, it's always x comma y. Okay, so the x value here is 2. The y value here is 4. And so the 2 is going to be my x1, and the 4 is going to be my y1. And I do the same thing for my other point. You don't have to use the endpoints if you don't want to. I just always prefer to use endpoints if possible. But you can use any 2 points you want as long as they fall on the graph. So this point right here as an ordered pair would be, what, 4, 0. Remember, an ordered pair is always x, y. So the 4 is going to be my x2, and the 0 is going to be my y2. Okay, so when I plug into the equation for slope, y2 is 0. y1 was 4 divided by x2 minus x1. Okay, so 0 minus 4 is negative 4. 4 minus 2 is 2, until you get a slope of negative 2, and so the acceleration is going to be negative 2 meters per second squared. In other words, every 1 second that passes, the velocity is decreasing by 2 meters per second. Okay, so that is the answer to question 2b. So pause there if you need to check your work. Hopefully that's the answer that you got. Okay, one more quick question. I'm going to erase this. Question C says from t equals 0 seconds to t equals 2 seconds, that is during the first segment, this object is moving with a constant velocity. Calculate the distance that this object would travel during this time frame. Now, we haven't done this exact type of question before, at least not one that looked like this, but the hint here is if we want to calculate distance and we know that it's constant velocity, remember, when you have a constant velocity situation, there is only one equation that applies, and that is d equals v times t. That is the only equation there is for constant velocity. So if I want to find the distance, that is my unknown, I know what the velocity is because I can look at the graph and be like, hey, the constant velocity is 4 meters per second in that first segment. Okay, now what is the time? Well, it's from 0 seconds to 2 seconds, so the time would be 2 seconds, because that's how much time passes between 0 and 2. So d equals v times t for constant velocity. Okay, v is 4, t is 2, and so that would be 8 meters. So that's the type of question we've seen before, but it's kind of got a little twist on it because we did it with a motion graph. Okay, so hopefully you feel a little bit more comfortable, especially about motion graphs, since you're about to take a quiz over motion graphs. Definitely look over your practice problems, definitely look over your notes before you take the quiz. Remember, you only get one submission on the quiz, okay, so make it count. As always, please let me know if you have any questions, and I will see you guys in the next video.